In this video, we are going to look at how to write equations for multi-step word problems. When you're writing any type of equation, remember, step one is to write a let statement to define your variable. Step two is to write your equation. Step three, solve your equation. And finally, write your conclusion statement, including, at the very least, a label for your answer. Let's take a look at example 1. Student Council is sponsoring a concert as a fundraiser. Tickets are $3 for students and $5 for adults. They want to raise $1,000. If 200 students attend, how many adults must attend? In this example, the missing information is how many adults must attend. So we're going to write let x equal the number of adults. Since we know they want to raise a total of $1,000, we're going to put that on the end after the equal sign. So the total that they want to raise is $1,000. If there are 200 students attending and each student pays $3 to get in, that is $3 per student times 200 students. Plus, they're charging each adult $5 to get in, but we don't know how many adults are coming or how many they need. So that is 5 times x. Now that we have our equation, we can solve to find x. 3 times 200 is 600 plus 5x equals 1,000. We can subtract 600 from 1,000, and from 600 to get 5x equals 400. And if we divide by 5, we find that 400 divided by 5 is 80 adults must attend. Take a few minutes to try these two examples. In this first example, we know that the total that the 7th grade wants to collect for the animal shelter is $500. So we're going to put that on the right-hand side after the equal sign. We know that they already collected $116 last week, plus this week they collected $78. We know they have 2 weeks left, and if we assume that they are going to collect the same amount each week, how much would they have to collect each week in order to reach their goal? So what we want to know is let x equal amount collected each week. And since there are 2 weeks, 2 weeks times x dollars a week, added to what they've already collected, we want that to equal 500. So this is what your equation would look like for this first problem. For our second problem, we know an electrician charges $50 per visit and $100 per hour for each hour that they work. If he makes 3 visits and the total charge was $900, how many hours did he work? So what's missing in this problem is the number of hours that he worked during those 3 visits. So if x is the number of hours, we know that his total was $900, and what made up that $900 was $50 per visit times 3 visits plus $100 an hour for x hours. So 50 times 3 plus 100x would equal $900. Now let's take a look at this second example in our notes. Pasha bought sandwiches and beverages for 6 people. The beverages each cost $4.50, and the sandwiches each cost the same amount. The total cost was $68.10. Find the cost of each sandwich. So what's missing here is the cost per sandwich. And we know that their total is $68.10, so we can put that over there. What adds up to $68.10 is sandwiches and beverages for 6 people. So 6 sandwiches and 6 beverages. You can write this a few different ways. You can write this as 6 sandwiches at X dollars each plus 6 beverages times $4.50 each. Another way to write the same problem is 6 times the price of the sandwich, which is X dollars, plus the price of each drink, which is $4.50, equals a total of $68.10. These equations both work. They both would give you the same result. If I solve this, 6 times x is 6x, and 6 times $4.50 is $27. So 6x plus $27 is $68.10. If I subtract the $27 from the total, $68.10 minus $27 gives us $41.10. And then lastly, if I divide that by 6, which you can't see because the green is at the bottom is not showing up on top of the green, so I'll write it over here. Divide by 6. $41.10 divided by 6 makes each sandwich $6.85 per sandwich. So that is our conclusion statement. Take a few minutes to try these 2 examples. In the first example, we are looking for how much they spent per cupcake. So X is the cost of each cupcake. And if we know that Brianna's parents spent $270 total on her birthday party, we can write the $270 after the equal sign. There are 40 guests coming to the party, and they're each receiving a $5 party favor plus a cupcake for X dollars. So we can write that as 40 times the quantity, 5 plus X equals 270. If you multiply 40 times 5 and 40 times X, you could write this also as 200 plus 40x equals 270. The 200 comes from the 40 times 5. In our second example, we are looking for the price of the bag of mulch before the discount. If we know the total is $22 after the discount and they're buying 8 bags, we can write this as 8 times the quantity X, which is the original price of the mulch, minus 75 cents, because we're taking 75 cents off of each bag, not off of the total of the 8 bags. So one way to write it is 8 times X minus 0.75 in parentheses, or you could say 8 times X, which would give us the original price of 8 bags of mulch, minus 8 coupons of 75 cents each equals $22. Taking a look at example 3, if Mary is 6 years older than her sister Kelly and the sum of their ages is 48, we want to know how old is Kelly. So in this case, we're going to write a let statement for Kelly's age. So let X equal Kelly's age. But since we have 2 people in this problem that we're talking about, we're going to also write a second let statement to represent Mary's age. Now, we do not want to use a different letter because we can only include one variable per equation. So if Kelly is X years old, based on the problem, what could we write for Mary's age? Well, it tells us that Mary is 6 years older than Kelly, so that is Kelly's age, X, plus 6. If we know that the sum of their ages is 48, that means that Kelly's age plus Mary's age equals 48. If Kelly's age is X and Mary's age is X plus 6, X plus X plus 6 equals 48 years. To solve, we can combine X plus X to make 2X plus 6 equals 48. Subtract 6, which gives us 2x equals 42. And finally, x equals 21. So we know that Kelly is 21 years old. And although it doesn't ask us for Mary, we could figure Mary out too now. Mary would be 27 years old because that's 6 years older than Kelly. Take a moment to try these examples. If we're looking for the amount of water that Jill carried, Jill will be our X value. Jill carried X pounds and Jack carried 4 pounds less than Jill. So Jack is X minus 4. And together, we know that X is Jill and X minus 4 is Jack. Together, they add together to equal 20 pounds. In our second example, we know that we are looking for the amount of students that get dropped off to Hampton High School by car. So we're looking for X is the number of students that arrive by car. We know our total students is 970. And we also know that the number of students that arrive by bus is 3 times the number that arrive by car. Together, the car riders and the bus riders equal 970. So that gives us an equation of X for those arriving by car plus 3X for those arriving by bus, as it tells us in the problem. Let's try this more complicated example. If we are looking for, in this problem, the number of Snapchats Caitlin receives, we're going to use X to represent Caitlin's number of Snapchats. Since Stephen receives twice as many as Caitlin, Stephen is 2X. And since Austin receives 4 more than Caitlin, Austin is X plus 4. Their total is 539. So altogether, we want to add Caitlin plus Stephen plus Austin to get 539. And for our final